Speaker for the afternoon is Guy Holden. He is the Vice President and General Manager of Johnson Controls FM and Real Estate Organization. And today he is here to share how building intelligence helps corporate real estate and facility management professionals make decisions based on insights provided by portfolio and workplace data. And that's your thing.
Hello, good afternoon. So this is very different. Just press the green one. Okay, so mankind have been creating information, writing things down for 5,000 years now. And in the last 2 years, 9 times more data has been generated than the whole of the rest of that 5,000 years. And we're really seeing, I think we're at the beginning of something really transformational for the way we see buildings, understand them, work in them. And I want to show you some examples today of how that's evolving, how it's working. And we're going to pick up a specific example around the workplace and some of the technology we're using today to look at real time, down to the 2-second use of a building. So big data is a commonly used phrase. It's a subject which is discussed in business environments and media. And I think that it's beginning to affect all elements of society, and it's absolutely, without a doubt, going to affect us in this room. It's going to affect the way we manage facilities, the way we use them, in a way that we don't comprehend yet. When you look at a portfolio of buildings or an individual building, we're going to drill right the way down from macro level global portfolio right the way down to an individual person on a day in a building. And I'll show you how that works. But the sort of data we're now getting out of buildings is extraordinary. Let's start with static data. For years, we've had standard static data that you take from a spreadsheet, or your input to a spreadsheet, or you use your real estate system or your facility management system. So on the real estate side, of course, we've got just the basic data of how many buildings we've got, where are they in the world, how do we hold them, do we own them, do we lease them, what sort of lease data breaks do we have, and what sort of agility and flexibility do we have here, what sort of condition are they in, what liabilities do they hold for the organization, what sort of transaction opportunities do we have, and all of that traditional real estate stuff. Sounds simple, and everyone says, oh yeah, we had that for years. But I'll tell you, I'm sure none of your organizations are like this, by the way, but there are many organizations who just don't have just the basic core static real estate data, and are beginning to get it in large quantities as they really understand their portfolios better. Of course, from the corporate sense, real estate is not seen like many in the real estate industry would see it as an end in itself, but it's actually a resource for the building. And certainly from my perspective, talking to senior folks in large corporate organizations, none of them are interested in buildings at all. They're interested in banking, they're interested in manufacturing, whatever it is they're interested in. And the buildings are just there to house the people and plant and process that enable them to do whatever it is they do. And so from a business resource point of view, the sort of financial analytics that we have, and there's a range here, and I'm sure you can think of numerous others, are things we've been doing for a long time. They're getting more sophisticated. We'll show you some of that in a second. But certainly financial-based static financial data is something that we use on a monthly, quarterly, annual basis. Because when you get into the operation of the building, you get a whole bunch of static data which is at a granular level of more detail. Maintenance data about the number of work orders being undertaken, about the criticality of assets. And some of these assets, we're talking about generic office buildings here, some of these assets are keeping data centers running, processing billions of dollars of transactions. That critical asset has got to work, we've got to know how it works. And there's a lot of statistical data being built up as to how they work, what causes them to fail, how long they last, and all this sort of data which are being done. Energy is transforming dramatically. A number of you will know some of the sort of demand response, the way demand response is changing, where utility contracts are with the contractors, working with real-time pricing and so on with energy suppliers. But of course, what's really transforming the data in buildings is dynamic data. So let's have a look at a little bit of that. On the facility side, and I've just picked up a random sample of these, and we're going to cover a few of them. So look, we look at security, we look at occupancy, and we're going to show you in a second real-time occupancy of the buildings. We look at critical environments and the performance of data centers, like I talked about a little bit, production uptime, surveillance for critical environments and so on, for critical public areas and so on. Lots and lots of dynamic data coming out of buildings in a way that we've never had before on this scale. Of course, utilities, as I say, is an area which is changing dramatically. I talked a little bit about real-time utility data, which is really transforming the way people buy electricity in particular, but buying and giving back at peak times to different utility providers as part of their sort of demand response contract. And of course, when you come to renewables, they're very unpredictable because they rely on natural phenomena, which are unpredictable in themselves, except for the UK where it always rains. Generally, you can't really. So understanding the data, performance data, the dynamic performance data of renewable technology is an important one as well. And of course, we can take that now right the way down to the individual piece of kit in a building, on a floor, on a Wednesday, and whatever level of granularity it may be, and I'll show you some of those. So, let's have a look at some real data. So this is from a portal we use for our own portfolio with a sample of data, Johnson Controls portfolio, which is a very big global portfolio. So we got our head of real estate, our head of facilities, or whatever we want to call them, looking at a whole range of dashboard of data, because this is at visualization stage. Now, analytics at this point, we're just bringing it together to look at it in a way that we haven't seen it before. So you've got a dashboard which brings all of this static and dynamic data together. So you can look at your individual buildings, you can slice them by maps, you can drill into them, I'll show you in a second, from the building to the person very, very quickly. You can navigate around the world, you can filter it by business unit type, by type of building. Sounds as if everybody's got it, but they don't. And of course, you can look at financial commitments against that. You can look at savings calculations from different portfolio management scenarios. You can look at portfolio optimization opportunities from collocations and so on, particularly after things like acquisitions and so on. And you can go from the static to the dynamic pretty quickly. This is a real sequence. We click on the building and the map, we look at the photograph of the building, we click on the floor plate, we click on it, we find out how that floor plate is being used now. And it might be in Munich, it might be in Shanghai, it might be in Sydney, it might be in New York. Energy, of course, is a massive area, and we can look at energy spend in multiple ways. This is still just visualization at this point. So these are basically a pie chart, and this is just another way to visualize where you're spending your money. Johnson Controls, it won't surprise you to know, but our HQ is the largest consumer of energy. But of course, the most intense consumer of energy is the data centers. This is just very simple visualization, but it tells you where to go and look first. Now we get down to comparing individual buildings. And you can look, this is excuse me, this is uploaded every 15 minutes, and you look across your portfolio and you can look at the profiles of energy spend. You can see the days and the weeks and the weekends coming down for each of the buildings here. So some of the buildings are actually pretty well managed, pretty well optimized. We'll show you some of the ways in which they've done that now. And they've really sort of got them down to very, very predictive here. This one at the bottom here is completely different. It's an aircraft hangar. And you can see the type of energy consumption there, which is random at that point. And you can overlay it with weather data, and you can do some real clever analytics around what happened here and what happened here. And you can filter that, and it gives you real insight into how your building is performing. This is an interesting one as well. So this is April, this is last month. So this is a set of data running from 24 hours during the day. And you can see the different the heat is a heat map showing different levels of energy consumption. So you really should be able to see the working day very quickly. And you shouldn't see this, and we certainly shouldn't see anything like this at weekends. You should be able to see those very quickly. And the more you optimize the energy performance of your building, the more clearly defined that should be. And the more you should be able to really understand the heat points if you really optimize the performance of your building. And of course, what we're now getting is dynamic occupancy for buildings, which we'll talk about in a second. But of course, the visualization of the data isn't enough. What we're able to do now is really provide some very powerful analytics, and it's in its infancy, but we'll have a look at some of these. So, what we can do here is we can set a series of parameters around pretty much anything you can think of, and anything that goes beyond these parameters, it will tell you there's a fault, and it can range from any number of things in the building. So, these are some examples. I'm rushing through some of these. This is some examples, real business examples, where we're using this type of data today for customers in specific business environments. Oh, pardon me, sorry. This is very simply how it works. You know, the data, as you've seen, we can collect a variety of data. This happens to be energy goes up, looks at reporting at the very basic. You can look at benchmarking. You can take the weather into effect. You can look at what should the energy be. You can benchmark that and you can predict it at a very simplistic level. What we're able to do, though, however, is actually send data back to the systems which originated them, which can then automatically change the way the building operates. Yeah? And so, you know, we can set levels of hierarchy according to the severity of the issue you're finding in the building. If it's a very simple one, you can dispatch somebody who sits in the building if that's what you think is needed. If it gets into a category of seriousness which requires some special, more deep diagnostic, you can send it off to a remote operations center which can dial into the building and look at it. Or, if it needs something really special, you can get somebody dispatched who's a specialist to look at something if it's a particular. All of that gets built into the analytics of the system. Nobody has to make a decision at this point. That happens automatically now. So these are the examples I was going to talk about earlier on. Very quickly, so this is a data center. Data centers typically, well, we're monitoring temperature within racks. Typically you'd find it's overheating we're worried about. This example was the thing where it wasn't overheating. We found that it was actually overcooling. And we changed the parameters to enable us to save energy there, whilst keeping it within the same parameters of the rack. This is interesting as well. This is not static data, but there's some sophisticated stuff being done here on this portfolio for a fuels retailer. This is static data on work orders over 15 months for particular types of kit. And you can look at it in that type of environment. You've got revenue generation in food, you've got revenue generation in the fuel itself being dispatched. So this is not about the building necessarily. But you can look at lighting, which is always their number one customer satisfaction thing on their feedback. You can look at lighting, you can look at temperature control. In this case, we were looking at dispenser uptime. The pilot we did in Italy showed a dispenser uptime improvement of 84% in uptime of those dispensers for this particular food retailer by analysing that data. Convenience store, I'm going to keep going with this. Convenience store, making sure that the refrigeration units which are actually storing the food at the optimum temperature. These are things that really matter to this organisation, not about the building, it's about what goes on inside it, at their core business. This is a big box retailer here, looking at big chillers, and they're obviously under huge pressure. They're saying, how low can I go? What do I really need to maintain? And we did a lot of analysis there using long-term data, predictive data about how they could optimise that. Skip this one. This is with a big global bank looking at energy analysis. Again, we found that the very simple predictive analysis you can do at the beginning is actually, we found, about 90% accurate when we get into the real detail of it. So just by very simple analysis like this, and we're learning an awful lot of things about how those buildings operate. This is an interesting one. So this is about root cause. So this is where rules get written into the algorithms, which says if we have a fault which gets to this level, it overrides all the others. If you have a fire in a building, you're going to get alarms going off everywhere. And of course you can't respond to them, you don't even know what's happening in them. You have to, so the one that your fire detection system says, there's a severity of a fire here, it ignores all the others. And it goes straight to the root cause. And you can build those in straight away now from scratch. So, let's look a little bit to the future here, and I'm going to talk a little bit about what we're doing in the area of workplace. So these are sensors that we're putting into workplaces now. We've done them in all regions of the world. 3 types: desks using heat, meeting rooms, and open spaces. We can understand exactly how those buildings are being used, the level of data, level of sophistication that's coming out of it, the level of ability to